So, good morning, students, and so we'll be moving to the today's lecture directly. So, in the last class, that is in last lecture, we have seen about the what we have seen. We have seen about the generation of a switching surges. Okay. So, how the switching surges are generated, and the principle behind the generation of the switching surges we have seen. So, in today's lecture, what we'll be covering is that so in today's lecture, and after that in the previous lecture itself, we have dealt with some of the introduction to your impulse current generation. So in the impulse current generation and what are the characteristics of impulse current generation we have seen. And in today's class, we will be covering with respect to the what you can say. Yeah, in today's class, we will be covering with respect to your generation. So the generation part of the impulse current today will be covering. Okay. So starting with based upon the thing we can see it can be casted into three. That is, impulse current generation can be generated using three methods. So first one is your trigatron gap, second one is your movable electrode, and third one is your free electrode gap. So these three are the things we will be seeing today in today's lecture. So in the starting of yesterday's class, we have seen about the introduction to your impulse current. So in that, I have concluded that the impulse current can be generated by charging and discharging of your capacitor. Okay, so that is we have seen the series RLC circuit by constant charging and discharging of your capacitor, it is possible to generate the impulse current. Okay. So what I say is for producing a very large kind of amplitude of impulse current, what you have to do is you have to make an arrangement like this. So in this is like you can see it's like a horseshoe magnet. And here what you can see is that there are very huge number of capacitors. And these capacitors has to be charged in parallel and also has to be discharged in parallel. Okay. Here there is no contribution in terms of a series connection. So all the capacitors will be in terms of a parallel connection. Okay. As I said, this arrangement is similar to that of a horseshoe arrangement. Okay. Why it is taken in terms of a horseshoe arrangement means by making these kind of arrangement, it is possible to minimize the load inductance. Okay, so your load inductance is the one which is responsible for your power factor drop. Okay, the power factor drop, as I said, your power factor has to be more or less maintained in terms of your unity, in terms of both your industrial as well as your domestic load. Okay, so in order to maintain such kind of power factor to be unity, we will be connecting some capacitor banks. Okay. So here also similar to that, the load inductance has to be minimized. For that reason, we will be making in terms of this horseshoe arrangement. Okay. So also the capacitors also will be subdivided into small parts. Okay. So it won't be taken as the entire capacitor. So this you can take it in terms of a split case capacitor. So in inductor motor, that is you might have studied starter, which is test capacitor starter. So similar to that you can take. So there the entire capacitor value will be subdivided. Okay, if you're taking for a 220 microfarad means the 220 microfarad will be contributed as 110 microfarad and 110 microfarad. So like that you can split it out. Okay. So here next what they have given is that they have given the inductance value. That is L0 is the inductance of the discharge path, L1 is of each group. So here they are grouping it. So it's grouping as L1 and L2. Okay. So they are giving the final inductance value in this format. So here N1 and N2 is nothing but the number of capacitors in the each group. Okay, so don't be confused about that. So the sphere gap the things which are responsible for your impulse current generation. Okay. Let's see. Here the sphere gaps are be arranged in the impulse generator. How it will be arranged means the sparking of one gap. Okay, sparking will be starting from one gap. Okay, which will be followed as a results in automatic sparking of the other gaps. Okay, so this you can understand as you can see that it will be like a cascading process. Okay, first one gap will be that is will be turning on one switch, and if you're turning on one switch, it will be contributing to the turning on of other switches which are connected in parallel. Okay, similar to that gap. So in order to trip the generator at the predetermined time and decide input voltage, we have three methods, as I said in the starting of the lecture. So first is your movable electrode. So here the tripping process will be based upon the electrode movements. The second one is your three electrode gap. So here three electrodes will be kept in terms of the electrode gap, and the third electrode is responsible for tripping of the generator, and finally is the trigatron gap. So movable electrode. So here what it is, you can see. So it's similar to that of your sphere gap concept. So here, in general, what happens is that the gap distance will be reduced. Yeah. So this gap distance is the one in which your voltage will be depending upon. So this one we have already seen in your previous lectures. Okay. So as the gap distance is keep on reducing, so how we can reduce the gap distance? By keeping one electrode as a fixed one and keeping another one electrode as a movable one. Okay, so at the initial stage it is kept at the distance d, and at the next stage it is moved to a distance of d1, and the final stage it is moved to a distance of d2. Okay, so based upon this movement of the electrode, it is possible to trip the generator and cause the impulse current. Okay, so the limitation in this is that it is very difficult to control. The precise control of the movable electrode is not possible. Okay, it does not assure a consistent and controlled tripping. Okay, so here the tripping is very difficult. Okay, the circuit is also complex. So moving on to the next one, three electrode gap. Okay, so this will be somewhat easier to understand. So here you can see this part. So this is where the three electrode gap comes into play. So the first case of the impulse generator is fitted with the three electrode gap. So this is the impulse generator, and the impulse generator it is fitted with the three electrode gap. The central electrode is maintained at the potential. So this is your central electrode. It is maintained at the potential. How its potential is maintained means between that of the top and the bottom electrodes is the resistor R1 and RL. So here you can see this resistor R1 and RL is nothing but a formation of your voltage divider circuit. Okay. So what happens? This electrode, third electrode is maintained such that it depends upon the value of this R1 and RL. So in general, what we'll be doing is that this pair gap will be generating the voltage. Okay, so the third electrode will be starting to trip it out, trip the voltage between this pair gap, and in turn it generates an impulse current over here. Okay. So here it has a circuit is a complex one. By seeing circuit diagram, so you can see it needs a very high state. So the next one is the Trigatron circuit. So here the Trigatron circuit is very easy to understand. That is, here it will be having electrodes. Okay, this is of spherical shape. Okay, and another one electrode will be of the main electrode. Okay, which is Earth. Yeah, you can get it right. This is your high voltage electrode, and this is your Earth electrode. So both these electrodes will be on the spherical shape. Okay. So here you can see the circuit diagram. Here is your Trigatron gap. So what it does? So the tipping of the impulse generator is affected by trip pulse. Okay. So here the manual control can be provided by the provided for the tripping process. Okay, but whereas in your three electrode gap and in your previous one, movable electrode, it is not possible. But in the Trigatron gap, here you can manually control it. Okay. So this produces a spark. By tripping, this produces a spark between the trigger electrode and the earth sphere. So this is your trigger electrode. Okay. This is your trigger electrode. This will be responsible for the tripping of your impulse generator. Due to space charge effect and the distortion of the scene in the main gap, the spark power of the main gap will be occurring. So it will be contributing to your impulse current generation. The Trigatron gap is a polarity sensitive and the proper polarity pulse should be applied. So this is a precaution. So the polarity has to be checked before turning upon or tripping of this electrode. So other normalities circuit for producing the impulse wave. Okay, this is in general. It is okay, this thing can take it for both current as well as your voltage. So this one we have already seen. So setting the simple Arnold circuit, RLC circuit, and they have taken the Laplace transform. This one we have seen already in your previous lecture. So this just a repeating. So here, as I said, it will be contributing to a second order system, and this second order system we have to find the roots. Okay, so I have to find the roots in order to check whether the system is a over damped or it is a critically damped system. Okay, so that's what they have given over here. And the solution for the equation is based upon these alpha and beta system in the roots. Okay, the same equation we have already seen in the previous lectures. So where is RLC? What we are covering again means this also you can generate your impulse current. Your impulse current quantities can also be generated in such form. So here why we are going for this RLC based means the wavefront and the wave times are controlled by varying the values of RL. So this I already said. So your RL is will be contributing for your time constant. Okay. So your RL term is contributing for a time constant. So based upon the time constant, your wave characteristics can be controlled. So what are your wave characteristics? Your wave characteristics include wavefront and your wave take time. Okay. So the main advantage is the circuit is very simple. Okay, circuit is very simple. The wave control is disadvantage what you can take. The wave control is not flexible, or you can take the wave control is independent. Okay. So with this, your impulse current generation is getting over. Okay. So in this, the main questions what you can expect is that you can expect the methods for the generation of your impulse current waveform. And the second one is based upon the on the 8-power current, and will be asking for the Trigatron gap. Okay. So with this lecture, we can just sort it out, and the unit also is getting over with this lecture. Okay. So thank you.